Alrighty guys, here's what we're going to do. We are going to talk about our concept map for forces and dynamics. Before I do that, I'm going to go ahead and write a few things out. Alrighty, first thing we're going to talk about is Newton's first law of motion. He has 3 laws of motion that we've covered so far. We're going to discover more as the class goes on. However, we're going to talk about Newton's first law of motion. And that's that an object at rest stays at rest, an object in motion stays in motion unless acted on by an outside force. That's a really way we can simplify that by saying one of 2 scenarios are going to be true. That's either A, our object has the summation of the forces acting on it, and either the x or the y direction is going to equal 0, or they're not going to equal 0. Alright. If they equal 0, that means all the forces on my object are balanced. That could be a box sitting on a table. That could be a box being pushed against a wall. It could be in outer space. There's a couple of instances where that could be true. And this is what we call as unbalanced. All right. When F net equals 0 and your forces are balanced, one of 2 situations have to be true. Either 1, your object is at rest, not moving, or 2, your object is moving with a constant velocity. And then if they're unbalanced, your object is always, and is going to accelerate in the direction of the larger force. So accelerate in direction of F net. Okay. That's pretty much it for Newton's first law of motion. Newton's second law of motion, however, is going to get a little bit different. Alrighty, now let's look at Newton's second law of motion. Newton's second law of motion is saying that the force on an object is proportional to mass times acceleration. And so if my mass increases and my force stays the same, acceleration should go down, and you should be able to play with these 3 variables overall. Now, when we're dealing with Newton's second law problems, or almost any force problem in this class, the first step you always want to do is draw a free body diagram. Now, I'm going to go ahead and write out my other 2 steps here. So after you draw a free body diagram, you're going to then break it into its components. I'm going to do a couple other videos that really help figure out how to break something into its components. But in this one, I'm just going to do a simple example, and then you're going to solve for whatever the question is asking. So solve for unknowns. So for example, in this first part right here, let's go ahead and switch colors real quick. I'm going to draw a box. Let's take this box and let's put it on a table. Let's take this box and put it on a table. If you're drawing my free body diagram of a box, what we do is we take from our center of gravity, we were going to draw straight down. And this is going to be weight. And then since the box isn't falling into the table or flying in the air, it's just resting there, it's going to have a force normal direction upwards. Now, since this box is not moving at all, there's no other applied forces. Now, if we're going to break this into its components, we would redraw this. And instead of saying weight, we could break that into its components and then say this is mass times gravity and force normal is equal to weight. Okay. When you're doing FRQs and asks for your free body diagram, we're going to use these and not its components. Components will help us figure out how to solve for the unknowns. So say, for example, the mass of the box was 10 kilograms. What is force normal? So 10 kilograms. What is force normal? Here we can then write our equilibrium statements and then solve for our unknowns. What that would look like exactly, we would say force normal is equal to weight. So force normal is equal to mass times gravity. And then force normal equals 10 kilograms times 10 meters per second squared. So force normal equals 100 newtons. Okay. Now I'm going to talk about Newton's third law of motion, and that is for every action there's equal and opposite reaction. So this is often called the law of action and reaction. So that's saying that the force applied to one object is equal and opposite to its reaction force. Okay. So what this means is if I were to take a box and I were to push it on another box, that means that the force that the one box is pushing onto the other one is equal and opposite to the box pushing back. So then we could say the force applied from box 1 onto 2 is equal and opposite to the force applied of box 2 onto 1. You could do the same thing of setting these up horizontally. You could do the same thing of setting these boxes up vertically. I'm going to do another example in a later part of the video of more of these complex problems of what happens if I have, how do I calculate the forces involved if 3 boxes are stacking onto each other? So sit tight for that example. That is coming up soon at the end of this video.